All right, camera set up. All right, guys. So tonight we're gonna go over, you guys have your first homework assignment at home, and we're gonna go over the notes from yesterday in class. So basically the first page of your homework, I'm gonna go ahead and go over this problem. The problem where Paul opens a savings account with $350. I know before the quiz today, I rushed through the notes that you were supposed to have taken on Monday, but if you did not get good notes and it was a little fast, go ahead and make sure that you guys have this. Obviously, if you took the notes on the front page problem, you don't have to do these. You don't have to do this problem for homework. You only have to do, as far as the word problem goes, you guys only have to do the one on the last page, okay? So let's go ahead and talk about this. So Paul opens a savings account. Remember, guys, we're going to go down to the bottom where it says I, okay? And we're going to make the table first. So it says, go ahead and draw a table. I always recommend you guys start with a table. Get to this one. All right. And I want you guys to make 4 rows for this table. It says that Paul opens a savings account with $350. Well, at this point, all we have is X and Y. So what you guys need to remember is if we're dealing with dollars, this is always going to be the Y value. So let's go ahead and put dollars here. If he opens a savings account with $350, that means that his first amount of dollars, or his initial, we're going to call this the initial amount. We remember initial to mean first. The first amount that he has in the savings account is $350. And it says that he saves $150 per month. And we also learned that the word per means division, okay? And this statement is a statement that tells us our slope, okay? Because we can take this and read this as $150 per month is $150 divided by month. Now, if we ask ourselves the question, how many months does it take him to earn $150 or to save $150? It's reasonable to suggest that $150 per month means $150 every 1 month. So make sure you include the 1. This tells us the amount of months. Now, if you put your delta Y and your delta X next to this, then you can now see that your Y unit is dollars. Notice I've listed the dollars here, and that your X unit is months, okay? So we're gonna list month here. And remember that these are our units, okay? And to get more values in this table is to use this slope value. So basically with these problems, you're gonna have a starting value, and then the slope's gonna tell you how to get additional values in the table. In this case, we're increasing $150 per month. We're increasing the amount in the savings account by $150 every month. So the next month, we're going to have 150 more, so we are adding 150 each time. So if this is 350, add 150. The next month, we're going to have 500 in the account. Add another 150. The next month, we will have 650. And the next month, add another 150, we're going to have 800. Now be careful, the last homework problem, it talks about a decrease, not an increase. Now, when we have an increase, we're adding. When we have a decrease, let's say the water level in a tank is going down, then it would be going down by a certain number of gallons per hour, right? So we would be subtracting each time rather than adding. So be careful here. Right here, we're adding 150, and this is our dollars. And we ask ourselves, how many months did it take him to have 350 in the bank? Well, when he went to the bank and deposited the 350, no time had passed. That's when the problem, that's the starting value, and therefore no time has passed. This would be 0 months. He saved 150 every month, so after 1 month, he increased the account by 150. After 2 months, he's increased the account by 150 2 different times. So he's increased the account by 300. And after 3 months, he's at 800. Then you guys have to take the table. You guys need to go to the graph. Now, I didn't provide a graph on the homework, so technically on the homework, you don't need to graph this. But I'm just going to talk to you guys again. When you guys are making when you're graphing this on the quiz, you need to look at your largest numbers, okay? Can I get to an x value of 3? Yeah, very easily. 1, 2, 3. So this is going to be my scale for x. But how do I get to a y value of 800? I only have 9 spaces here, so I need to make each space a distance of 100. So 100, 200, 300, 400. We're changing the scale, guys. 500, 600, 700, and 800. Okay, so this means 8 spaces is all it will take for us to get to 800 because we made each distance 100. Okay, let me make sure the camera is recording. Okay, all right, let's go ahead and plot these points. 0, 350, this is a y value of 350. And since it's a y value of 350 and we have an x value of 0, this is going to live on the y-axis, halfway between 300 and 400. Okay. Then 1, 500 is going to be right 1 up 500. Notice with the 350, we put this point halfway between 300 and 400, so it does not lie on a corner point. 1, 500 lies on a corner point. 2, 650 is going to be right 2 up 650, but we don't have a 650 in our scale. We have 600 and we have 700, so 650 is going to lie in the middle, and then 3, 800 is going to be up here. Now we're going to connect these points, asking the question, can I have the number of months increasing? Can this be 4 months and have $950? The answer is yes. The number of months can continue to increase. So can I continue to increase the x values? Yes, I can. That means this line will extend to the right. But will the line extend to the left of the y-axis? The answer is no, because if you look at this, does it make sense to have an x value of -1? Realize that if you go to the left of the y-axis, your x value would be -1, your x value would be -2, and since the x-axis represents the number of months, it does not make sense. We can have +1 month, +2 months, but it does not make sense to have a -1 month and a -2 months, so therefore the line will start at the y-axis and go to the right. Now, one more thing I forgot to do. Remember that these are the variables. And notice that I forgot to change the variables from x and y. So we're going to make these variables match something with respect to these units. If I'm talking about months, why don't we call the xm? And that means for our x-axis, notice I have the unit of months, but I need my variable. The variable for the x-axis is going to be m. Now for dollars, we talked about this. We're not going to use D for dollars. We're going to talk about what the dollars are representing. In this case, they're representing an amount in the bank. So in this case, we're going to use A for amount, capital A. This is truly your choice unless the problem tells you which variables to use. This problem did not tell us which variables to use, so that's why I'm choosing these to be M and A. Technically, you can get away with using whatever you want. And if there's nothing mentioned, technically you could get away with using X and Y. So let's make this A, and A, the unit, notice I'm putting the variable A, and then I'm putting in parentheses the unit that we're counting. Notice I do not have 350 amount. I have $350. I do not have 1 M. I have 1 month. Okay, so notice for M I put months, and for A I'm going to put what? Dollars. I want the unit next to the variable. The variable is M, the unit is months. The variable is A, the unit is dollars, okay? So let's go ahead and start answering these questions. Part A asks for the linear model. I'm gonna write this, and then we're gonna leave this on the board, and I'm gonna have to erase because the camera screen doesn't go all the way to the right. Let me make sure. Yeah, we have enough space. The camera's picking up this. Okay, so linear model, if you see this phrase, you will see this phrase in word problems. What this is talking about is the equation. Okay, so go ahead and cross out linear model and write equation. Okay, that's what it's asking us to do. So on part A, it says write a linear model that represents the total amount of money Paul deposits into the bank after M months. So basically what you're doing is you're just writing the equation for this, and the equation is y equals mx plus b. I'm going to use blue. I'm going to darken this up. I think the camera can see the red quite fine, but darker colors make it easier for you guys to see on the camera. So y equals mx plus b, what we're looking for is the slope and the y-intercept. That's all we have to do is replace these. So we're going to write y equals, what is our slope value or our m value? Well, that is our per statement in the problem. Notice we already calculated this earlier as $150 divided by 1 month. If we're gonna put this into the equation, we're only interested in the numbers. We're not interested in the units. So what is 150 divided by 1? That is 150. So that means the slope is 150. X, you're gonna insert your y and your x, plus, now where do we get that y-intercept b from? That comes from that initial starting amount, or the initial amount in the bank. Notice this is also where the graph crosses the y-axis. The graph crosses the y-axis at 350. The initial amount in the bank was 350. That is your y-intercept, so we're gonna put plus 350. Now remember, you guys have to write this in terms of the variables for the problem. So instead of using y and x, I want you guys to write this. Instead of y, we're using capital A. This is A equals 150 what? Not x, but we're using m. There's one additional thing that you guys need to do for the test and for tomorrow's quiz. You guys need to make this equation, well, let me write it again. This is not wrong. A equals 150 m plus 350. I want you guys to realize that we can take the x variable and write it also next to a, and it means the same thing. We read this as the amount of money after m months is equal to 150 m plus 350. These equations are the same thing, and you guys are going to have to recognize that a and a of m are literally the same variable in algebra. Although the bottom equation looks more complicated, it actually is more useful in the future, and I'll show you why later. This is a better notation. So I want to see a of m, meaning just take your x variable and just set it next to your y variable. Just make sure you put it in parentheses. What is this reminding of? This reminds us that y is the same thing as f of x, okay? It's just visually getting used to this. It's going to take some time, okay? Now, I'm going to erase all of this to save camera space. And I'm going to put this equation right here. A of m is equal to 150 m plus 350. So basically all you had to do, guys, was take your per statement, that's your slope, and take your initial amount. The problem is giving you your slope. Excuse me. The problem is giving you guys your slope and your y-intercept from the information, okay? And we're going to skip B. B is not required for the notes. We're going to do C. Part C says to write an ordered pair in words. Now, I told you guys in class, what I mean by words is I mean units. So cross out words and put units. And you are just going to make an ordered pair like this. You're going to make a point, and you're just going to take the units from the table and set them here. So our X unit is month. So that means we're going to have months. And our Y unit is what? Dollars. Don't use M and A. Do not use your variables. Use the things that you're counting. Do I have 500A? No, I'm not counting A. I have $500. The units are what we're counting. Do I have 1M? No, I have 1 month. Okay, I'm going to continuously say that. So these are the units. And the unit pair is going to help us interpret what things mean. So let's go to, I need the space. So I'm going to erase this. And I'm going to put the unit pair right here. Month, and dollars. Okay? Now we're going to go to part D. On part D, you have to calculate A of 8. What does this mean? Well, what this means is you're going to put 8 in for M. If you don't see that, take this equation and write it directly underneath A of 8. So A of M is equal to 150M plus 350. Now, the way you read this is you say the amount in the account after M months is equal to this, 150 times M plus 350. This is how you would calculate the amount in the account after M months. In this case, we're looking for the amount after 8 months. Notice that the 8 is going to replace the M. Once you write this equation, just erase your M and put the 8, and come over here and erase your M and put the 8 in parentheses. Now what you have to do is you have to calculate this part. The A of 8 is just a symbol. The amount after 8 months is how we say this, is equal to this calculation. So remember, when you calculate this, we have multiplication, we have addition. You guys have to do the multiplication first. So we're going to do 150 times what? Times 8. How do we do this? We're going to do 8 times 0, which is 0. 8 times 5, which is 40. We're going to take the second digit, which is a 0, and put it here, and we're going to carry that 4. 8 times 1 is 8. Add the 4 is what? 12. So we have 1,200. So these two multiplied give us 1,200. And to that, we have to add 350. If I add 350 to 1,200, you just add straight down. 0 plus 0 is 0. 0 plus 5 is 5. 2 plus 3 is 5. And 1 plus nothing is 1. So we end up with 1,550. Now we have to interpret what this means. To interpret this is to say, okay, I have a point here. And that point has an x value of 8 and a y value of what? 1,550, and all we have to do is look back to our unit pair to understand what this means. And you can easily make sense of this by looking at that unit point that we made. This means 8 months, $1,550. Let's clean that up and put that in words. What that means is after 8 months, the savings account will have $1,550. Okay, that's good enough. As long as you're mentioning 8 months and that the account will have $1,550, you're good. No matter which way you say it, just make sure you're talking about both of these in your interpretation. Okay, let's go to part E. You guys can always, the nice thing about watching the videos, guys, is you can rewind and relook at that. Okay, I'm just going to erase it. And month and dollars. Let's do part D. No, E. We're on part E. Now part E says to find M when A of M is equal to 1,550. Okay, so here we're going backwards. We're going the other way. So again, when you have these types of, like, what is the equation used for? This guy right here, the equation that you found at the beginning, is used to find unknowns. Unknown values. So when you're asked to find unknown values, you're just using the equation to do this. So just rewrite the equation. A of M is equal to 150M plus 350. And notice, what is it asking us to find? It's asking us to find M, or asking us to find the number of months. Okay, so we have to find M, so we don't know M, but notice what the problem gives us. It says that A of M is 1,550. So this means that the amount after M months is 1,550. They are giving us this. So what we can say is if A of M is 1,550, we can just cross out the A of M and replace it with what? 1,550 equals 150M plus 350. Now we're going to draw a line down that equal sign, and we have an equation to solve. To solve for, because we're finding M, we got to solve for M. We have to take this 350, move it over here. That's to subtract 350. And what does this give us? 1,550 minus 350 is 0 minus 0 is 0. 5 minus 5 is 0. 5 minus 3 is 2. And 1 minus nothing is 1. We get 1,200 equals 150M. Now you have to divide by 150, and I'll show you a trick. To divide by 150, notice that you have two numbers here that end in 0. When you're dividing two numbers that end in 0, you can erase at the bottom. How many zeros can we erase? Well, we can erase 1 0 on the bottom. Therefore, we can erase 1 0 at the top. So you can almost like canceling out zeros. What you're doing is you're dividing the top and the bottom of the fraction by 10. So now what you have to do is you have to figure out how many times 15 goes into 120, and you can start by counting your 15s. So 15, add 15 more, you get 30. Add 15 more, you get 45, 60, 75, 90, 105, and 120. And if you count this 1, 2, 3, 4, 5, 6, 7, 8 times, it took 15 8 times to go into 120, so 120 divided by 15 is 8. Now if we interpret this, the interpretation What we have to do is we have to say, okay, we have that point. What was our M? Our M is 8. That goes here. And what's the amount of dollars? Well, that's the A of M, or the amount after M months was $1,550. So what does this mean? It's the same answer as what we answered in part D, that after 8 months, there will be $1,550 in the bank account, okay? Part F. Part F asks for the domain, reminding you guys that domain are your X values. So what you guys need to do is you need to open a brace and close a brace, and we're going to put the X values in here. So let's go to the chart or the table and look. Which ones are the X values? And they are these, okay? The first column is your X, second column is your Y. So the first column is our domain, and the second column is our range. So your Y values are called range. In this case, the amount in the bank is the range, and the months are the domain. So we're going to list, the domain means what? The months. How many months could we have here? Like, what are the possibilities for the number of months? Could I have 0 months? Yes, I could. Could I have 1 month? Yes. 2 months, 3 months. Could I have more than 3 months? Yes, he could continue making money. 4 months, 5 months, okay? So 4, 5, does this continue? Yes, it does. Does it continue forever? No, it does not, because time does not continue forever for an individual person investing money in the bank. So we will talk about what a reasonable end is. Maybe he works for 2 years and he's saving money for 2 years. Well, if he's saving money for 2 years, that would be 24 months. Okay, so maybe a reasonable end to this would be up to 24. Maybe he works for 3 years. 3 years, since there's 12 months in a year, 3 times 12 would be 36 months. So maybe we could argue that 36 is a reasonable end to this domain. Okay, so notice I put ... and then I put the 36 at the end. On a multiple choice test, they would give you stuff like this. They would say, what's the reasonable end to the, like, what's a reasonable domain? They would say 0, 1, 2, ... This would mean goes on forever. That's not reasonable, because this person's not going to be able to work forever. He's eventually going to die, okay? Like, there's an end to, like, all of us have a finite existence, right? We're not going to live forever. Therefore, he cannot continue to work for an infinite number of months. On part B, it could say 0, 1, 2, and then it would end. Well, in this case, that's not reasonable, because he's probably going to work for more than 2 months, right? Like, if we just did this problem, like if he's saving in the bank, I would say they would probably give this. Maybe they wouldn't. Hard to say. Maybe B is a possible answer. I mean, he could work for just 2 months. They could give something like this: 0, 1, 2, and ... up to 1 million. Well, I can show you that we can calculate that we don't live 1 million months. Okay, we talked a little bit about that in class today. That at 70 years times 12, if you live 70 years old, 70 years times 12 months would be 840 months. Okay, so we're definitely not 1 million. But they could do something like this: 0, 1, 2, 3, ... up to, say, 48. Well, 48 is 12 months times 4 years, right? So that would mean he's saved for 4 years. So the answer would be B or D. And I doubt that they would cause you this type of confusion, but I would say reasonable would probably be the case that he works for 4 years. Let's just act like B was not an answer, because technically it could be. And let's just say you were comparing A, C, and D. The answer would be D. Reasonable domain would mean it would stop somewhere maybe like 48, right? Okay, all to say, the emphasis with this is that the domain is not going to go on forever, guys, in these application problems, unless it's a certain rare situation. Off the top of my head, I can't think of a case where, well, let me think more about that to come up with an example that would clarify this better for you guys. Domains that are infinite versus domains that are finite. Okay, finite meaning that there's an end to it. G, okay, it says, what is the y-intercept? Well, we have the y-intercept right here. The y-intercept is where it crosses the y-axis, and the y-intercept was what? 0, 350. And to interpret this means that we just have to look to this unit point. This means after 0 months, $350. This means that he has not worked. I'm sorry, not that he hasn't worked. The initial, the best way to say this is use the word initial. When you have a 0, initial deposit amount into the bank, or you could just say initial deposit amount was $350. This means that's what he put in the bank before any months had passed at this point. And lastly, we ask what is the x-intercept on part H. What is the x-intercept? Well, if you look at this, the x-intercept requires that you have an x value, but the y value is 0. In order for the y value to be 0, well, I could go to the graph. Let's go to here. In order for the y value to be 0, that would mean the dollars are 0. And if you look in this context, we're never talking in this context about a bank account having a value of 0. And if you look over here at the graph, does this line extend to the left down to the x-axis? The answer is no, because we talked about months can't be negative, right? So the best way to say this is there's no x-intercept. Because rather than talking about the amount, which is the range, I would rather you guys talk about the months, which is the domain, okay? It's better to talk about domain. No x-intercept because months cannot be negative in this context, is the answer. Okay, and we'll talk more about this as time goes on. I'm not so concerned with these last two. But anyway, hopefully that helps, guys. And as far as the systems, graphing the lines, I think we made that entirely clear. I'll do one quick example. If you take and go to the back side, if you take your front page, right, front page of your packet, flip it over, go to the back side, and we're going to look at the top right problem, okay? The top right problem is y equals 4x plus 3 and y equals negative x minus 2. We call this a system of linear equations. Why do we call it linear? Because it's a line, right? What are these? Each of these is an equation of a line. This is a line, this is a line. We have two lines, and the solution of this will be where the lines cross. Now, I use the word cross. Let's use a different word. Instead of saying where the lines cross, where the lines what? Intersect, okay? So in order to do this, we have to graph each of these lines. Now to graph them, I'll do the first one in red. So we're looking at this last number. This last number is our y-intercept. Since it's a positive 3, we have to go where on the y-axis? We're going to go up 3 units to start. Okay, so up 3 units is the point at which the line is going to, or our starting point in order to graph the line. Now our slope will be the number that sits in front of x. In this case, it's a 4. And remember, you have to write your slope as a fraction. If you have a 5, that's the same thing as 5 over 1. If you have a 6, that's the same thing as 6 over 1. What is 7 divided by 1? That's 7. What is 8 divided by 1? That's 8. So if you have a number for a slope that's not a fraction, you need to turn it into a fraction by writing the 4 as 4 over 1. This is delta y over what? Delta x. If delta y is positive 4, we're going up 4. If delta x is positive 1, we're going right 1. So from here, you're going to go up 4, 1, 2, 3, 4, right 1. I'm running out of space. Can I reverse my direction? Yes, I can. Instead of going up 4, right 1, I can go down 4 and left 1. Okay, again, down 4, left 1. Here's our line. Okay. Now, for the second one, we're looking at our y-intercept here is negative 2. So we're going to graph that point. We're going to go down 2 units on the y-axis and graph this point. We're going to grab our slope. Now, the slope is the number in front of x. Since there is no number, but we have a negative, that represents negative 1. Again, we have to write this as a fraction, so this is going to be negative 1 over 1. This is delta y, delta x. So if delta y is -1, we're going down 1. If delta x is +1, we're going right 1. You just need to do this until these lines cross. So we're going to go down 1, right 1, down 1, right 1. Uh-oh. Are we getting closer to where they cross or further away? We're obviously getting further away, so we need to reverse the directions. Go back to your original starting point. Instead of going down right, we're going to go up left. Up left. Have we drawn the lines so that they cross each other? Yes, we have. Now what we're going to do is we're going to look for that point of intersection. This is our solution. And the solution is going to have an x value and a y value. So we're going to look at this. What's the y value? The y value is -1. What's our x value? Our x value is also -1. So we're going to put the x value first, and we're going to put the y value second. And this is the answer to the problem. And hopefully that helps you guys with your homework. Go ahead and finish all pages in this packet. Remember, on Google Classroom, I posted only the pages that are required. The back side of the second page where it says solving systems of linear equations by substitution, you do not have to do this page, okay, for tomorrow. But the rest of the packet needs to be completed, and I will see you guys in class tomorrow. I hope you guys have a wonderful night.